Hey.
All right. We have a next talk here, but before we start, I would like to repeat some announcements. So don't forget to rate every talk on shed.com. Don't remember that today there is a social event party at Flavio. It starts at 7 p.m. And also don't forget to join tomorrow's closing session where you will be able to win some prizes. And by that, I would like to welcome on stage Flavio, who will give you a talk about deploying OpenStack on Kubernetes with Ansible. So floor is yours.
Cheers. All right, let's get started. I'm not sure if this is the last talk of the day or not, but it does feel like it. Anyway, so deploying OpenStack on Kubernetes with Ansible. The only word I'm missing here to hit the buzzword bingo is blockchain, but I'm not going to talk about blockchain today. I'm sorry to disappoint you. We are going to talk about OpenStack, Ansible, and Kubernetes. So before we get into the actual content, that is me in case it isn't obvious enough. Thank you all for being here. I know it's late. I know you're all tired. I know some of you have traveled from far away. That is my Twitter handler. If you like this talk, you can just comment on it. And if you don't like it, that is not my Twitter handler. And I was never here. But I do like feedback, so feel free to follow me. Someone has to feed my ego, and that's you. That is my email address. If you don't have Twitter and you don't want to tweet me anything, feel free to comment and send feedback. I work at Red Hat. I'm still working at Red Hat, and I'm part of the OpenStack team. So that's where I spend most of my time in the last couple of years. I've been working a lot on deployment tools and trying to focus on containerizing OpenStack and deploying it on containers because they're going to fix the world. So a couple of disclaimers. Some of the things that I'm going to say today are still work in progress. So don't expect all of the things that I'm going to say today to just work out of the box, because they're not. And what else? I have 23 minutes, actually probably 20 minutes and 30 seconds to finish my talk, and I have a lot of content. So what I'm going to say is going to be a really high level. It is your homework if you are expecting to leave this room without homework. It is your homework to just go and deep dive into these kind of things. And if you are interested, just come to us and we'll happily provide more information. Why on Kubernetes? Why deploying OpenStack on Kubernetes? This is something that some other folks have talked about already, but I feel like it is important for us to always go through why we're doing this and why it is important and why it benefits the OpenStack deployment. One of the reasons is service isolation. Once you put your services inside containers, you have your services isolated from other services. You isolate dependencies. You have more control on what goes into the container and what you are actually running. Of course, it adds some extra layers of complexity into the entire picture, but it provides some features and it helps on these kind of things. It makes upgrades easier. Because if you've ever looked at OpenStack, how many of you are familiar with OpenStack? Quick show of hands. All right, enough people. So OpenStack is a massive beast, and the services are interconnected. The dependencies are common to most of the services. We are trying to reuse as much as possible when we build this massive piece of software. And whenever it comes to upgrading, it's not only hard to upgrade the services per se, but there's also the interconnection, the dependencies between these services makes it even harder, because when you upgrade one of the services, you might be breaking also another service that you have running in your cluster because of the dependencies that they have into the same libraries and some other stuff. And to that, you can also add that some of the services depend into each other, and you got to plan very well how you want to do these upgrades. So by containerizing OpenStack and putting it on Kubernetes, we can leverage some of the upgrade capabilities of Kubernetes. So it's not going to solve all the problems again, but we can use some of the semantics and the primitives that exist in this COE that actually was built to manage these kind of applications. And there's also this belief that OpenStack is a massive stateful application. It is really not. Some parts of Some parts of it are, some of the services are, but it is not entirely stateful. There are many API services that can be treated and looked at as a cloud-native application. And I was trying to give this talk without saying cloud-native, but whatever. I failed. Deployment flexibility, it allows us to not always think ahead about how many nodes and stuff that we want to put into our cluster. We have some extra flexibility because we can depend, again, on some of the semantics and primitives that are available in a COE like Kubernetes to actually scale out or scale down our cluster, add more nodes, et cetera, et cetera, et cetera. So it provides some nice things to have when you are deploying such a big application that is critical for your infrastructure. Well, is of scalability, again, like it just makes it easier to add more containers, add more nodes, and remove them from the cluster as we move on. Options. What options do we have? Of course, there are many options. If we want to deploy OpenStack on Kubernetes, the first and most obvious one when we start doing this, and this is actually something that I did with another colleague of mine. We were looking at how are we going to deploy this thing on Kubernetes. So the first thing is just get the Kubernetes YAML files, start writing your own YAML files, try to play with it a little bit, see how it works, see what kind of resources you want to use, see what kind of like primitives and services from Kubernetes you want to use, et cetera, until you figure it out, and then you say, all right, let's automate this thing, and let's actually stop playing with it. The POC was nice. Let's make a product out of it. Now, you don't want to make a product out of just like plain YAML files. That's painful. Been there, done that. Never again. OpenStack-helm. That is another project that exists in the OpenStack community. As the name suggests, it uses Helm. And it's a great project. Well, if you're familiar with Helm, if you're not familiar with Helm, actually, it's the simplistic way to put it is a way to package Kubernetes YAML files, basically, and Kubernetes applications, and make it simpler to deploy them in a Kubernetes cluster. Now, it is an OpenStack project. It is part of the OpenStack community, or the OpenStack umbrella, if you will. It has support for most, if not all, of the services already, and it works out of the box. It's quite a neat project, except that it uses Helm, and Helm was a problem for us for different reasons. But I think one of the main motivations to not wanting to depend on some service like Helm is, first and foremost, well, it does have an extra service that you have to take care of. And yes, like I'm aware that you can also install the tiller service, that you can take it down and you can just run it whenever you need it. You can also use Helm to generate the templates yourself and just feed them into Kubernetes. There are ways to go around this issue, if we want to call it issue. But then when you have like bigger deployments that you want to manage, Helm doesn't seem to solve or be performant enough to manage these kind of deployments and provide process and control on the process of deploying these applications. I think they have gotten better and better at it. But at least when we started looking at this and we were like deciding what to do and whether we wanted to use Helm or not, this was one of the problems that we had. So another option is kolla-kubernetes. Kolla-kubernetes is another OpenStack project. It also lives under the OpenStack umbrella. It uses Ansible, so it was almost perfect for us, but it also uses Helm under the hood. And what it does is it basically creates Helm charts and uses Ansible to manage these Helm charts, generate YAML files for Kubernetes, and then it fits all those YAML files into Kubernetes later on. So it is kind of like, it is Ansible, but it's kind of cheating because it's also using Helm under the hood, which is not really a problem. Again, like it's just generating YAML files and basically putting them into Kubernetes. So the good thing about it is that the way you execute it is by executing Ansible rules, which is something that we definitely wanted because we wanted to have that ability to have full control on the deployment process and be able to organize it as we want it. And we wanted to speak to, Ansible to the entire process. Now, again, like it is using Helm under the hood, and that was a problem for us from a technology perspective, integration perspective, because this whole work we're doing as part of the Triple community And what we're looking for was a way to create these roles to deploy OpenStack services and so that they could exist as an independent project and that people could consume independently from all the other applications in the OpenStack community. But that would also allow us to integrate them with some other tools like OOO and some other deployment, again, tools. So the other option we had was just looking into pure Ansible roles, and that's exactly what we did. It provides us with the ability of, again, controlling the entire deployment process, and we are familiar with it, and that is and not only us, like the entire, there are many people in the community that are actually familiar with Ansible already. So there was a more like an optional, okay, we want to use Ansible, but what exactly we want to use to communicate with the Kubernetes API. So why Ansible? Adoption, it's easier. There's more adoption of Ansible out there. There are more people using Ansible. There are more DevOps and operators using Ansible already that are familiar with the tool. So we wanted that to be our interface. It'll make it simpler for people to actually understand what's going on there. So if you already have Kubernetes and you want to deploy OpenStack, you don't have to go and learn how Helm works, what services you need to keep running or anything. You just know that you know Ansible, you take Ansible, and you use Ansible for that. So this adoption also provides a bigger community, and we want to be able to have a community that not only supports us in the development process, but that also allows us to create a new community out of it that will help us maintain all these roles that are independent from all the other tools that we have. Integration, it is easier to integrate with other deployment tools. Again, like the interface is known, we know how to use Ansible. There are other tools, there are other Ansible roles and playbooks being developed and used in the community, so it's just simpler. So how we're going to do this? It is all magic. I know I'm going fast. Again, I have like really short time to go through the entire thing. So there are two ways. If you've ever looked at using Ansible to talk to Kubernetes, you probably know there's these ansible-kubernetes-modules repo somewhere or a project that it is part of the Ansible organization on GitHub. And you can use it to talk to Ansible directly. It is a set of modules, and this is an example, actually. It is a set of modules that, so it is auto-generated. All these modules are basically auto-generated. They go into the Kubernetes API, they introspect it, and generate these modules with, you can see it says Kubernetes. I think there's a pointer here. I'm scared to hit anything. Anyway, line 26. I don't think you can read the line number. But anyway, it's Kubernetes V1 service. So it translates the API into Ansible modules that you can use. Now, this is great. This was working for us. But after talking to the Ansible community and the other guys, actually Chris that was here right before me, we kind of figured out that this maintaining auto-generated modules was actually causing more pain than solving problems, because these modules need another library that needs to again, like introspect the Kubernetes API. So it's hard to create a module that is API version independent and that is easier to ship and maintain. So since this is very dependent on the version of the API that the module was generated with, it would have been really hard to have backwards compatibility and forward compatibility with all the modules. So what we did is we created a brand new Kubernetes_raw module. It is coming out in Ansible 2.5. And this is an example of how it works. Kubernetes raw. And it is one of the differences also between this model and the Ansible Kubernetes modules is that this one is actually part of Ansible. We can ship this with Ansible. The other one, we couldn't ship it because, again, it depends on things that are auto-generated. And one of the rules in the Ansible community is that you don't just auto-generate modules and ship them inside Ansible. So this module is easier to maintain. We have names of people that are behind it, mine included. And the way you use it is you call Kubernetes_raw. You set the API version you want to talk to. You set the kind is the kind of the service, the endpoint or resource that you want to interact with in the Kubernetes community. And you pass all the metadata. So you can see already, it's very simple. it feels a lot like writing Kubernetes YAML files. The difference, the real difference here is that you have full control on the execution process and how you want to organize your workflow to deploy the services. So that's the real power behind using Ansible for this thing instead of just writing Kubernetes YAML file. But there's more to it than just being able to control the process, and we'll get to that in a bit. So if you see the main, I'm not sure if you noticed that this is out of the documentation in the module. This is coming from one of the roles that have been written already. So you can tell that we have not upgraded all the modules yet, all the roles yet, because this thing here is coming in Ansible 2.5, which hasn't been released yet, as far as I know. But anyway, as soon as it is released, we are going to upgrade the existing roles for the OpenStack services. So getting into more details, try to give as much details as possible. So in the deployment process, now forgetting a little bit the tool, let's stop talking about the tool a little bit and focus on what we're using, what resources we're using in the entire deployment process. And again, I'm just going to give you high-level information here. And if you have other questions, we can talk after the talk, and I'll give you more details if needed. So one of the first things, use jobs to bootstrap the services, and Ansible inside them. What does it mean? So if you're familiar with how OpenStack is deployed, there are many bootstrap processes that are involved in the deployment process. So you get the service in the server, you install it, you create a database, then you synchronize the database, then you run the service. And that is the simplest case. For some other services, you also need to create, like in the case of Keystone, you need to create the fernet keys and some other stuff. So all these kind of things need to happen before you run the service. And right now, the way it is done in most of the cases is that you just get into the server, run these operations on the node, on the host, and then you exit, and then you're done. You run the container or the service, and that's it. You get it running. So one of the things you can do by using Kubernetes is that you can just run the jobs inside the Kubernetes cluster. And if you tie these with config maps and secrets, then you know you can run these jobs anywhere in the cluster. It doesn't really matter where they're running, because they're going to run isolated from the rest of the things and pods that are running in the cluster. They're going to do whatever they have to do. They're going to create a database. They're going to synchronize it. They're going to create all the config files and put them in the places where they have to go. Now, the interesting thing is that since we can talk to Kubernetes using Ansible, and we have Ansible already as a tool, you can write all these jobs using Ansible itself and run Ansible from within the container that is running the job. So you use the same language, you provide the same capabilities, and you provide the same pluggability to the entire process, even on the jobs that are running inside, on the containers that are running inside of these jobs. Config maps for configs. We put everything in config maps, all the files that are generated. It is not only key value, we actually load the XC keystone files into the config maps, and same thing for all the fernet keys are into secrets, are going into secrets. But anyway, all the configuration files are going into config maps because we want everything to be independent from the host where the Kubernetes cluster is running or the service is running. Secrets for credentials and fernet keys. Again, we generate the fernet keys, put them in secrets. We use the secrets for the cloud information, the authentication, all the keystone access, data. It all goes into secrets. We use Statefulsets for databases. So now, Statefulsets are a cool thing. They don't provide, though, all the semantics and I really don't have all the information and details on this specific matter, but one of my colleagues actually does. So Statefulsets are awesome for services that require HA to some extent. So they always require one of the nodes to be available, and provide more semantics to actually have extra control on how you want to manage HA for this specific service. They're not perfect out of the box. And in fact, this other colleague of mine, which is dedicated into the HA architecture, he worked on some operators and other tools that actually help maintaining the database running in the most sane way and provide HA. Excuse me. So the reason you want to use Statefulsets for the database is because it is a service that it always has to be running in the cluster. So if one of the nodes goes down, you want another one to be available as soon as possible and make sure that it is accessible by all of the other services running in the cluster. So one of the other things you want to do is use the Kubernetes DNS. And we found out that, so there's kind of like a gray area here. Like you want to use the Kubernetes DNS as much as possible for the inter-cluster communication. So if you have a container talking to another container or a pod talking to another pod, you want to use the DNS as much as possible so you don't have to hard code IP addresses anywhere. You have a more flexible deployment and more flexible architecture, because that is one of the things that we actually want to get from this whole work that we're doing. However, one of the things that we hit was that we were using the Kubernetes DNS, and that was perfect because from the jobs we can access the DNS, et cetera, et cetera, et cetera, until we actually wanted to access the OpenStack cluster from outside Kubernetes. And in that case, we didn't have access to the Kubernetes DNS, and we also had to configure the host to be able to consume the Kubernetes DNS. So use the DNS as much as possible. It just makes configuring the entire cluster simpler. Remember IP addresses. Remembering IP addresses is hard, and it also kind of like hard codes and makes your deployment less flexible. Let's see if I have more. Yeah, well, still, things to do. Still, create the rest of the roles. There are actually not that many roles that have been created yet. So the MariaDB role exists, the RabbitMQ one, the Keystone, Glance, Cinder. And we're working on the Neutron one, and hopefully starting to work on the Nova one very soon. So if you're interested and you want to play with Ansible, Kubernetes, and OpenStack at the same time, by all means, come and help us. And also, we're missing integration with other tools. So we're starting to look into this. As I said, I work on deployment tools. I'm part of the O team, upstream in the OpenStack community. So one of the things we want to do is eventually be able to consume these roles from O and control the entire deployment process using O as an integrator for the entire thing. But one of the keys behind this work is having independent roles that people can consume without depending on a tool as big as O is. And so if you're interested in only using Keystone, you can just take the Keystone role, install it, and be happy with it. The same thing you can do with the Glance role and the Nova role, et cetera, et cetera, et cetera. And if you have your own tool for deploying things, you can just take the roles, integrate them into your tool, and you're done. And I was told that I was out of time, so I beat you. Done. Thank you.
So this was the last talk in this room for today, so I would like to kindly ask everyone to grab your things and leave. Ideally, if you can take your garbage and leave the room as clean as possible, that would be lovely.
Thank you.
Thank you.
Thank you. Yeah. Give me a hug. How's it going? Go ahead. Right. I was. Okay. That's